Hi everyone, Dr. Beena here. Today's topic of discussion is corneal metabolism. Cornea is an excellent piece of tissue with dual or different properties like mechanical support and the transparency. So it has got important property of maintaining the mechanical support for the eye and also for the transparency. And it is a major refractory medium. Now we'll pass on to the layers of cornea. There are 6 layers: stratified squamous epithelium, Bowman's membrane, stroma, Duar's layer or the new layer, then Descemet's membrane and endothelium. These are the 6 layers, out of which Duar's layer is the new layer. Here you can see the various layers, that is epithelial layer, then Bowman's membrane, then comes the stroma, and after that Descemet's membrane and the endothelium. So in this diagram you can memorize the layers in an order, that is A, B, C, D. So first A is the anterior epithelium, B is the Bowman's membrane, C is the corneal stroma, and the D is the Descemet membrane and endothelium. So you can remember all the layers like this. Now, what is transparency? Transparency is the quality or state of transmitting light without appreciable scattering so that bodies lying beyond are entirely visible. So transparent means the bodies which is lying above, in front of the eye are visible to the person. So here cornea has got the property of maintaining the transparency for the eyeball. So cornea absorbs ultraviolet light, transmits visible light of 400 to 700 nanometer, infrared light up to 2500 nanometer, and the peak transmission of 85 to 99% is in the visible spectrum. The rest of the 1 to 15% is scattered in different directions, that is violet affected most due to the cellular components. So usually the cornea absorbs UV light, but it transmits visible light of 400 to 700 nanometer, and infrared up to 2500 nanometer. Peak transmission 85 to 95% is in the visible spectrum, and rest is scattered in different direction due to the cellular component of the cornea. So normal corneal transparency is maintained by the physical and anatomical factors and the physiological factors. Physical and anatomical factors are normal precorneal tear film, uniform regular epithelium or endothelium, then lamellar area of stroma, cellular factors, corneal avascularity. These are the physical or anatomical factors which influence the transparency. The physiological factors are relative dehydration and uniform refractive index of all layers. So these are the various factors which influence the or maintains the transparency of the cornea. So corneal transparency results from the uniform spacing on the collagen fibrils in the substantia propria. So due to the fibrillar arrangement of the corneal collagen fibrils is one of the most important thing in the corneal transparency. Any increase in the tissue fluid between the fibrils causes cloudiness of cornea. Suppose there is an increased quantity of fluid in between these fibrils of cornea collagen, then there will be clouding of the cornea. Endothelium and epithelium play a major role in limiting the fluid uptake by the corneal stroma. So similarly, endothelium or epithelium play a role in the limiting the fluid uptake into the cornea. So that also limit. And the other thing is the lamellar arrangement of the collagen fibrils. Now we'll see the composition of cornea. Water 78%, collagen 15%, other proteins 5%, keratin sulfate 0.7%, chondroitin sulfate 0.3%, hyaluronic acid and other salts 1%. Now what is the function of tear film in maintaining the transparency? Maintains the normal healthy environment for the corneal epithelial cells. So it forms a normal healthy environment. The outside it is covering like a corneal epithelial cells are uniformly covered by the tear film. The inner mucin layer lines the hydrophobic epithelium and make it wettable. So the inner mucin layer of the tear film lines the hydrophobic epithelium of the cornea and make it wettable. Then aqueous layer and the superficial lipid layer decreases the evaporation. So you know there are three layers for the tear film, that is lipid layer, aqueous layer and mucinous layer. So the aqueous and the superficial lipid layer helps in decreasing the evaporation of the cornea. Tear film and aqueous humor are relatively hypertonic. So both aqueous humor and the tear film are hypertonic. An osmotic gradient exists between cornea and the hypertonic tear film anteriorly and with the aqueous humor posteriorly. So anteriorly, cornea and hypertonic tear film protect, and then behind, that is with the aqueous humor posteriorly. So these two limits the movement of water into the cornea. So that will protect the cornea and transparency is maintained. Now, biochemical composition of corneal epithelium. What are the biochemical composition? 10% of the total weight of cornea is by the epithelium, and water 75% of that weight, and protein synthesis in the epithelium is the highest, and phospholipids and cholesterol forms 5.4% of dry weight of the epithelium, and it contains enzyme necessary for Krebs cycle, for the glycolysis and for the sodium potassium ATPase. Acetylcholine, ATP, glycogen, glutathione are also present, and electrolytes potassium, sodium and also chloride. So these are the biochemical composition of the corneal epithelium. 10% of the total weight by the epithelium and 70% by the water. Then proteins are there for the synthesis of epithelium. Lipids, phospholipid, cholesterol, and contains enzyme necessary for glycolysis and TCA cycle. And acetylcholine, ATP, glycogen, glutathione, everything is present. So electrolytes also present. So in the cornea, collagen fibrils 70%, soluble proteins are there, proteoglycans, keratin sulfate, and enzymes are there. Matrix metalloproteinases, MMP 1, 2, 3, and some electrolytes also present in the epithelium. Water is 70%, enzymes necessary for the metabolism, then acetylcholines are present, electrolytes also present, that we already discussed. Now in this table you can compare the various electrolytes in plasma, tear and the cornea. Cornea, again it is divided into stroma, epithelium like that, and plasma and tear film. Each sodium, potassium and chloride, its level is shown. Here you can see whole cornea 156 milliequivalents per liter sodium and 28 milliequivalents per liter potassium and 97 chloride. In the stroma it is 172 and 21 and 108, and then epithelium 75, 142 and 30, and plasma it is 151 and 5.2 potassium and 109 chloride. Tear film 149 milliequivalents sodium and 12 milliequivalents of potassium and 131. So, but you have to know something about the cornea. Tight intercellular junction account for the normal transparency and the brief barrier function. So there is tight intercellular junction which plays an important role in normal transparency and the barrier function. This junctional complex prevents passage of tear film into the cornea, loss of tissue fluid from the cornea into the tear film. So these complexes will prevent the passage of tear film into the cornea and also loss of tissue fluid from the cornea to the tear film. So it maintains a steady fluid content in the stroma of the cornea. So tear film abnormality and corneal epithelial abnormality so produces loss of transparency. So whenever there is any disorder of these two, tear film or the corneal epithelium, there will be some loss of transparency because passage of tear film to the cornea is prevented by the junction complex. Similarly, loss of fluid from the cornea to the tear film also is prevented by the junctional complex. So whenever there is any tear film abnormality or corneal epithelial abnormality, they produces loss of transparency. Now the next layer is the corneal stroma. Stroma, 90% of corneal thickness, 75 to 80% water, 20 to 25% stromal lamina, that is laminae, that is collagen, extracellular matrix cell, that is keratinocytes, are also present in the stroma. Then matrix contains proteoglycans, mucopolysaccharides, collagen laminae in a hydrated matrix. So this is the composition of corneal stroma. Lattice arrangement of the corneal fibrils maintains the transparency of cells in the cornea. Now corneal stroma, it contains soluble proteins, albumin, immunoglobulin and glycoprotein. And the proteoglycan, glycosaminoglycan factors like keratin sulfate 50%, chondroitin sulfate 25% and chondroitin 25%. Again, there are glycolytic and Krebs cycle enzymes present in the corneal stroma. Then matrix metalloproteinases MMP1, collagenase, MMP2 gelatinase and MMP3 stromylysins. These are the seen in the corneal stroma. Then electrolytes and salts. Next is the Descemet's membrane, composed of collagen 73% and the glycoprotein. Proteins are insoluble and extremely resistant to chemical and enzymatic action. So does not contain glycosaminoglycan. So here in the Descemet's membrane, it doesn't contain glycosaminoglycan. It mainly consists of collagen and glycoproteins. They are insoluble and extremely resistant to chemical and enzymatic actions. Now the endothelium. Its single layered structure contains enzymes for the glycolysis and Krebs cycle. So it is a single layered structure containing enzyme. So these are the diagram. Now corneal metabolism. We are passing on to the metabolism. Most active layer for the metabolism are epithelium and the endothelium. Energy for the formation of ATP is produced by the breakdown of glucose. So, we are getting energy mainly from the glucose oxidation. Source of nutrients are oxygen, glucose and amino acids. Oxygen we are getting from epithelium, derives oxygen from tear film and the limbal capillaries. So oxygen is obtained to the epithelium from the tear film and also limbal capillaries. Oxygen required as 1/10 of the available from the atmospheric air when eyes are open, and 1/4 of it from the palpebral conjunctiva when the eyes are closed. So oxygen is obtained like that. It is required oxygen 1/10 is of that is available from atmosphere when the eyes are open. Only then we can get the atmospheric oxygen, and 1/4 of it needed is obtained when the palpebral conjunctiva is closed, when the eyes from the conjunctiva when the eyes are closed. So like that we'll get the oxygen. Epithelial oxygen we are getting from the aqueous humor. So for the endothelial oxygen from the aqueous humor. So epithelial oxygen that is derived from the tear film and limbal capillaries, out of which 1/10 is available from the atmospheric air, that is when the eyes are open, 1/4 from the palpebral conjunctiva when the eyes are closed. Corneal consumption of oxygen is 9.5 ml oxygen per centimeters per hour. Now corneal metabolism, glucose metabolism. Primary substrate for the epithelial cells, stromal cells, keratinocytes and endothelial cells. Rate of consumption of glucose is 100 milligram per centimeter square per hour and metabolized mainly by three pathways: anaerobic glycolysis, TCA cycle, HMB shunt pathway. So you have studied all this: aerobic glycolysis, TCA cycle and HMB shunt pathway. Anaerobic glycolysis produces two molecules of ATP. TCA cycle, 1 molecule of glucose will produce 32 molecules of ATP. So lactic acid formed will be eliminated from the cornea by diffusion through the epithelium. So whenever there is anaerobic glycolysis, lactic acid will be produced. That will be eliminated from the cornea by diffusion through epithelium. HMB-Shunt pathway produces NADPH, produce an NADPH produced, and it is used for the lipid synthesis by cornea. And the ribose produced is utilized to build the DNA or RNA and for the nucleic acid synthesis. And in epithelium and endothelium, the HMB-Shunt pathway break down 35 to 65% of the glucose. So up to 65% of glucose breakdown is occurring by the HMB-Shunt pathway. In the stroma, metabolize very little via this pathway. Pyruvate is the end product of glucose metabolism in the stroma. It's very little glucose metabolism occur through HMB-Shunt pathway, and pyruvate is the end product in the glucose metabolism in the stroma. Now the amino acid metabolism in the cornea. Amino acids supplied from aqueous humor. So it is usually obtained from the aqueous humor by the passive diffusion, and it is required for the synthesis 10 milligram per hour of protein for constant shedding and replacement of the epithelial cells of cornea. So that is the most important need of the proteins, that is for the synthesis of protein. Arrangement of stromal lamellae. There are two theories, Morris theory and theory of Goldman. Now, how is the arrangement of stromal lamellae occurs? Forms the basic structural framework of cornea and forms 70% of the dry weight of cornea. This stromal arrangement makes 70% of dry weight. Its main function is transparency and tensile load. So the transparency of the cornea is maintained by this stromal lamellar arrangement of the cornea, and also the tensile strength also is maintained by that. Stromal lamellae are composed of collagen fibrils. The structure of collagen fibrils are triple helical structure, 2 alpha and 1 beta, and diameter 35 nanometer, and its spacing is 55 nanometer, and it is remarkably a constant. There are 13 types of collagen in human cornea. Type 1 is the most common, that is 58% is constituted by type 1 collagen fibril. Type 6, 5, 12 and 14 are also there. Collagen monomers are assembled in a surface recess of keratocytes inside the cell. So it is arranged on the surface recess area where of the keratocytes. Central cornea contains about 300 lamellae, and the peripheral cornea around 500 lamellae. Most lamellae are arranged from limbus to limbus, and in some they cross adjacent lamellae too. So some normally limbus to limbal arrangement, but in some cases some of them crosses the adjacent lamellae also. Now, third major component is the proteoglycan. You know what is proteoglycan? It is protein plus glycosaminoglycan. Water-soluble glycoproteins, keratin sulfate, chondroitin sulfate, dametin sulfate are present. Protein plus glycosaminoglycans forms the proteoglycan. Extend to the interfibrillar space, that is usually seen in the interfibrillar space, and it acts as a pressure exerting polyelectrolyte gel. So it acts as like a pressure exerting polyelectrolyte gel. Maintains the spatial order of the collagen fibrils. Cornea collapses to 20% if the proteoglycans are precipitated out. So whenever there is precipitation of these proteoglycans, the cornea will compress to or collapse to 20%. Development of transparency correlates with the dramatic increase of keratin sulfate, proteoglycan, and in early postnatal life. What is relative dehydration? Water content of normal cornea is 80%, which is the highest water content in any of the connective tissue of body. So 80% water content is there in the corneal stromal tissue, but normal cornea maintains itself in a state of relative hydration. So how it is happening? Even though it is contained 80%, it maintains the relative dehydration. What factors to draw water, and there are factors to prevent the entry. So factors to draw vector is equal to factors to prevent the entry. So which are the factors? One, stromal swelling pressure and the intraocular pressure. The second is the barrier action of epithelium and pumping action of endothelium. So these two are the main pressure. More than 80% of water, if it is present, corneal swelling occurs. Stromal swelling pressure, keystone of corneal biophysics. Pressure exerted by the glycosaminoglycans in stroma. It acts like a sponge. Stromal pressure 60 millimeter mercury. Electrostatic repulsion of anionic charges, GGG, and expands the tissue and sucks fluid in. So with equal but negative pressure, that is imbibition pressure. So there is stromal pressure and the imbibition pressure. Stromal pressure is equal to imbibition pressure in vitro, but in vivo intraocular pressure comes into play. So imbibition pressure is equal to intraocular pressure minus the stromal pressure, that is 20 minus 60, that is minus 40. Stromal pressure generates interfibrillar tension, biophysical mechanism by which fibers are maintained in normal arrangement and then reciprocally activate the chloride channel. Then intraocular pressure is minus stromal pressure is the imbibition pressure. So if intraocular pressure is more than the stromal pressure, more positive in imbibition pressure, stromal edema occurs. This correlates well with the clinically detectable corneal edema. So when in that cases you can detect the corneal edema. If IOP is more than 50 by slit lamp, stromal edema can be seen. Even if the stromal pressure is low, sometimes corneal edema can occur. Now, what are the barrier function of the epithelium? Corneal epithelium is equal to 2 times resistant to water entry than the endothelium. Epithelium acts as a perfect semi-permeable membrane for the small solutes like sodium chloride and urea. So they act like a semi-permeable membrane for the solutes like sodium chloride and urea. These solutes are used in solution bathing cornea to produce hypertonicity. So sodium chloride solution and urea solutions are used in solutions for bathing the cornea to produce hypertonicity. Then barrier functions of endothelium. Endothelium is 10 times thinner than the epithelium. The solids diffuse across the layer. Water is extracted osmotically and the barrier function is calcium dependent here. So here the endothelial barrier function is mainly due to the calcium, and endothelium has got 10 times thinner than the epithelium and the solids diffuse across the layer. Water is extracted osmotically. Sodium potassium ATP is from several fold active than the same epithelium, extrudes sodium and takes in potassium. Overbane on eye produce corneal overhydration. Bicarbonate dependent ATPase in mitochondria. Bicarbonate depletion occurs. Bicarbonate depletion from incubation and perfusion media induces swelling. So bicarbonate depletion from the incubation and perfusion media induces swelling. Carbonic anhydrase enzyme exclusively in corneal endothelium. They produce bicarbonate ions and hydrogen ions. Inhibitors decreases fluid flow from the stroma to aqueous. So that is the action of carbonic anhydrase enzyme, that exclusively they present in the endothelium and produce bicarbonate and the hydrogen ion. Inhibitors, this carbonic anhydrase inhibitors decrease the fluid flow from the stroma to the aqueous. Sodium hydrogen pump. This complex series of metabolic reaction takes place in epithelium and endothelium to maintain the proper fluid and ionic balance and detergents. So that is the main function of sodium and hydrogen pump. Now what is corneal avascularity? What is the importance of corneal avascularity? Cornea is avascular except for a small loops which invade the periphery for about 1 millimeter. So whole of the cornea is avascular except for a small loop which invades the periphery for about 1 millimeter. So several theories have been proposed to explain the corneal avascularity. A vasoinhibitory factor of Mayer and Chaffray. Sulfate esters of hyaluronic acid acts as a vasoinhibitory factor. Then another is the mechanical theory. So there are two theory, vasoinhibitory factor of Mayer and Chaffray, and then the mechanical theory. In the mechanical theory, blood vessels cannot invade the cornea due to compactness of its structure. That is the theory. Blood vessels cannot invade the cornea due to the compactness of its structure. It's arranged in such a way that the corneal vascularity is due to the vasoinhibitory factor and also the mechanical theory. So the cornea remains avascular even in the states of hypoxia such as those induced by eyelid closure during sleep or in coma. In both these conditions, there will be closure of the eyelid and that will induce hypoxia. So even then the cornea remains avascular, and in a variety of ischemic and occlusive disease states also. So the cornea remains avascular when there is a hypoxia condition during sleep or coma or in a variety of diseases, that is occlusive diseases or the ischemic diseases. Only the cornea without epithelial layers develop blood vessels, implicating the role of epithelium in suppressing the blood vessel growth. So whenever there is loss of epithelial cells for the cornea, sometimes blood vessel can develop there, and then that may produce some complications. So without epithelium, only the development occurs in the cornea. Otherwise, cornea is always avascular. So that finishes the metabolism of cornea, and the usual questions are the metabolism of cornea as such, or corneal transparency, which is explained by the corneal various factors, and also corneal avascularity. That also is important. So that finishes the metabolism. Thank you.